Okay, hi everybody. It's Tuesday, May 24th, 2016. Therefore, it's the Keshe Plasma Reactor Group night. And I'm Rick Crammond, your host. And I guess we're ready to dive into it here once again for another couple of hours of fun in the sun. Sun being the plasma. Hey, right on. Okay, I'm going to turn the video over to Lee Coates here. He's got yet another interesting looking device here for us to ponder today. It looks like a spherical object in the middle there. And it's got the proverbial coils in it too, it seems.
This is a work in progress. I haven't finished. I haven't got the lid glued on yet, and I haven't aligned the thing so that it spins in the center. So,
okay, now is this got it's got the coils are on a separate rotation axle or a separate motor than the
that's right. We got a motor up top here.
Right.
That's with a speed control on it,
mm-hmm.
and that's just going to spin the coils.
Mm-hmm. Right.
It can go either way, forward, reverse.
Mm-hmm.
And then we got another motor on the bottom that'll spin the glass. This is just a glass tumbler I bought at dollar store for $1.50 or something.
And
then
how did you
then I cut a piece of glass that I got to glue on the top here. Once I figure out where the alignment is and get it.
I see. Yes, right. And so there won't be any seal there. It'll just be open at the top, kind of, or how are you going to do it?
On top of this glass, there's a little half-inch.
Sorry, we lost your audio briefly there.
Plastic tube glued. Okay, we got just a little plastic tube glued to the glass plate, just because I think it's going to slosh around a bit. So it's always going to be open on the top, but. That's just so the liquid doesn't slosh out so much.
Right, so it'll be open to atmospheric pressure and the air and so on.
That's right.
It'll be able to expand as
if you have to, you can throw a couple of O-rings in there with some O-lube. That'll seal it up nice.
That's a possibility.
Work for the speed you're working at. It's probably be under 2,000 RPM, probably more like 1,000 or something.
Yeah, definitely. It's probably under 1,000, maybe even, because it's the glass it's a blown glass, and it's not all that.
Yeah. You don't want to take that up too high.
We're going to be wobbly anyway. Let's put it that way.
Yeah.
And I'm sure the copper coil inside isn't very well balanced either. But
well, that's the thing. The copper coils can't take too high of an RPM either. They'll twist out of shape and so on.
Yeah. So anyway, well, what's my question for you guys is, what's the best Gans plasma water to load in this thing? What do you think?
Well, he suggested right off the bat use about 70% CH3 and 30% lead Gans. Water, of course.
Yeah. But
you may have to adjust those a little bit. That's roughly what Armin was using.
Okay.
Just judging by his measurements, he just gave volume measurements, but I'm trying to convert those into percentages because nobody has the same size of containers. Now, one thing I was wondering about, Rick, would you put enough liquid in that glass jar so that the coils are running in liquid, or they're going to be running in the void created by the centrifugal force of the liquid? Size of containers.
Yeah, that's a really good question. I pondered that idea myself, and especially at high speeds, what occurs in that voidness in the middle. It's a good pondering question. For example, if you had, let's say it was plasma water that was in the container, and you started rotating the container, well, it will start climbing up the walls first of all and forming a sort of a bucket of voidness in the middle. It'll be, air and vapor, but then won't you have plasma vapor coming from the plasma water perhaps? So that voidness in the middle perhaps will be filled with plasma vapor rather than, or with air as well, of course, but perhaps the air might be sort of forced out or can cohabitate along with the plasma vapor at the same time. And if that's the case, then maybe you want the coils rotating in that plasma vapor rather than the plasma water. But on the other hand, there seems to be some advantages to the idea of having it right in the plasma water. And would you be counter rotating them, Lee, one against the other?
I can do it either way, so I'm not sure what. I think there's several experiments to be done here.
Yeah, I think if
Yes.
you're counter rotating against the pressure of the water, you're going to deform your coils really easily.
But
Because there's
then
going to
you,
be, water's pretty viscous. It doesn't want
that's
to
right.
move, and it doesn't move very fast when it does. So you're going to be really limited with the speed of your central core.
Yeah, well, even if the central part is turning slower than the outside part, it'll be as if it's going the other way almost.
Yeah, it's your combined speed there that might be important. Like, we're looking at the actual flow of the plasma water against the coils. You know, that the Gans and nano of the coils. Is that part of the effect, or is it simply the rotation of the fields of the coils in the fields of the plasma water itself? You know, is it the just the fields that are interacting, or do we need any contact between the physicality of the water and the coil themselves, the coil itself, like?
Right. And then the next question, I guess, to look at would be how are those coils wired together? What did you do with the two ends that normally would go in and out?
I just wired them together. What was the other problem? What do I do with them? Because
Right. So it's
these are actually power coils, so they're double coils.
yeah,
So I
that's what
wired.
I understood. That's what I understood was required, and that's basically what I built. Mine are about half of the size yours are. I used like 24 gauge wire, 1/8 and 3/16 mandrels. And I guess my outer coil is about an inch and a half diameter. But I haven't wired them together yet because I haven't figured out how to do it. Are we energizing it with a plasma battery? Is it just a feedback loop? I mean, we got a lot of details there that aren't available yet.
Yeah, well, I couldn't figure a way to get the wires out of the glass jar to connect anything to them. So basically, I just twisted the two together.
Do you know how? Do you
Yeah.
remember how
Wrapped
Keshe
it
did it?
around the spindle there. But
Sorry, Rick. Go ahead.
Do you remember how Keshe did it?
I don't think he revealed it.
Oh yeah, it's been revealed. Maybe I can come up with a picture. I don't know if I've got it offhand though.
Okay, because
Yep.
the only other thing I could think of would be a commutator, but I know plasma doesn't like that sort of thing.
Well, it
So-
is. That's exactly what I was going to show. Remember, the early reactors have the rings on them, the 3 or 4 rings at the top of the reactor, the Iranian reactors.
Oh, really
that
old
Keshe
ones,
showed.
yeah.
Yeah, the really old ones, the gas ones. Well, they had probes that went inside, or different electrodes or whatever that went inside the reactor, and he would have the commutators on the outside to be able to receive power or use the sensors or whatever to be able to access the inside. So those rings go to separate wires that go inside.
Okay. Well, that's an interesting way to look at it.
So you could, for example, put voltages into your situation inside, create a current in the coils, or you could take off power or measure the power from the coils.
Right. Yeah, if you're dealing with matter state electricity.
Yes, right, or as an indication of some sort of fields.
Yeah, no, I was thinking of just a purely plasmatic system. How are you going to get a plasma commutator? You got to have nano coating to nano coating, which isn't going to last very long.
Well, the plasma commutator would be you would allow the fields to expand beyond the boundaries of the reactor, I figure. and you would pick up the fields either with another reactor where you could, magnify and reflect it back, or absorb it with another reactor, or just use those fields. You could attempt to measure them. I'm not sure how easy they are to measure. They seem somewhat elusive unless you have unless you're just measuring magnetic or electric or electrostatic or some sort of relatively ordinary type of field like that. But it may be some sort of torsion field that we need to be measuring, and it might be a little trickier to measure.
Yeah, I'm probably on the wrong track, but I just had a flash in my head of a commutator that uses Gans as the transmitting medium. So
Right.
the rotating part would be rotating against the bath of Gans, and that would be running up against the stationary portion.
Mm-hmm. Well, that's an idea. Mm-hmm.
Like they used to do the mercury commutators for the high voltage stuff.
Mm-hmm. Yeah. Well, I can show something kind of interesting I just ran into tonight, actually. Which, let me show a website here. Do a share. Do you want to get back to you there in a minute, Lee? Do you have some more stuff you want to show about your system? Or do you want to discuss?
I think that's about it. I'd say it's work in progress at the moment, and thank you guys for your input here.
Yeah, it's
That's
really cool. I think it's got lots of possibilities. Goes back to some of the early work we did in a way, but the coils are this new addition. So let me show something about coils that I ran into. It maybe are relevant. Do the screen share here.
Really, really nasty Tesla coil. All right.
Yeah, this is not a Tesla coil. It's way different, but yeah, it looks like it. It's shown above the experimental base for exploring field density in copper coils and copper density spheres. Right? So field density. He talks about these three fields: the tempic, the electric, and magnetic. Each has a field density offering a different distance and motional range, where the highest energy in its field will appear as a magnetic field is produced in the copper coils. And he talks about the fall off of these fields, and electric is with the distance squared, it falls off. The magnetic is with the distance cubed, it falls off. And this tempic is a linear fall off. And he relates these to the electron and proton shells in copper atoms and so on. And he has this whole theory and so on that goes along with it. I should mention the website here and get it up so people can see, and it's part of my public duty here. It's at resonantfractals.org/magnetism/field density. And it goes on. He goes on here about talking about the angles and the field separation that can occur. This is very interesting. He talks about he actually has a picture here. I mean, this is the picture we've used of the two coils forever in the last months, and Keshe's used. We have the actual coil here that he talks about, a round coil. And he talks about the electric field and the torsion field within this coil. And he talks about pulsing the coil with AC, and how pulsing the coil with AC can cause a certain rotation of these fields, and can separate the electric field from the torsion field, which are normally they're interacting, and they're always together in a way. It's hard to separate them normally. So he says that a certain way you can work with the back EMF and so on, and actually separate these coils and change the field into this other vortical sort of electric and torsion field, and mentions how you can get extreme voltage surges in the one other coil from the coil that has the AC coming in it. So he's noticed these extreme voltage surges that can occur and so on. And I thought that, it's very interesting. It seems to go along with the 129 Tesla that was measured by Keshe at one point. And then he shows some of his tests with this sphere and how he takes these different readings and pulses it and so on, and talks about the electric field density, especially at the poles. And he keeps mentioning about how the protons and electrons get aligned and whatnot. And he eventually gets into some other stuff about creating a conical nuclear magnetic resonance battery. Essentially, it's quite interesting, and talks about the different coil windings that can be experimented with on the copper sphere, and the voltage gradients that can be observed from it. You can see his probes here and coils on a copper sphere. And he talks about the spin. There's a spin. The South Pole flips up, it will spin clockwise, and as the North Pole flips up, it will spin counterclockwise. So on the flipping of the poles that Keshe has talked about before, that he's noticed in his early experiments, and so on. It's you'd have to get into it as a technical reading in a way to get out of it what you need if you're into that kind of technical details. But there's something that seems to something rings true about this in terms of our teaching of the Keshe stuff, about these two fields that are rotational fields, and about the coil. And they interact as if they're spinning, basically, and that changes things. So anyway, that's quite interesting. And there's another part to this. Let me see here. This one. He's got a just a second here. He's got an article on magnetism at the resonant fractals as well. He gets into all the different spins and so on, the momentum and magnetic moment, and about charge and magnetism and spin coupling and a bunch of other things. And some of it actually could be quite important for us to, important little factoids that might help with some of our Keshe stuff, different relationships and ratios and so on. And he talks about the neutron and how putting together the a proton electron to create the neutron, and so on and so forth. Here's the forces of interaction between the electron, proton, and neutron. And again, you see the similar diagrams that what we've seen before, like Figure 4, for example, looks like a sphere within a sphere. It looks like a field or a core reactor core within another core. And essentially, if you look at figure 5, it's another similar one. And you see how the fields are reversed. I hadn't considered that before, but the inner core, the south, is facing upward, and the outer core, the north, is facing upward, which actually makes sense because they'll be attracted to each other. If we try to have everything north up, then the north poles and the south poles would all be repelling each other, tending to have an unstable arrangement. So it makes sense that an inner core and outer core would have opposite signs as far as the north-south or entry and exit poles go, it seems. And again, it's this interaction of the magnetical and the what he calls electrostatic, but it could be considered gravitational, perhaps, magnetical gravitational, and the interaction of spin with these, and the change that spin makes on these situations. He talks about how gravity gets involved with this as well, and how to create gravity with these fields. So, and it goes on and on here. He shows this experiment with magnets, for example, neodymium magnets, where if you put this column of powerful magnets together with another column at their centers, they virtually do not interact at all. There's no magnetic attraction there. So it's an interesting idea with this thing of fields and how they interact. And he talks about using a non-magnetic material to split electromagnetic fields, and so on. The avalanche effect. And anyways, this goes on and on. I'm not sure how much I should get into it here. We'd have to really dive in to probably get it. But starts to get into iron and copper. Why copper's so good of a selection for the substance, and about aluminum, how that it's affected with the magnetic fields. Gets into cobalt there and so on. Mentions other devices, Smith coil, a bismuth core coil, that could be very interesting. We've talked about using lead, for example, in cores. Well, this is, he talks about using bismuth. And bismuth, I think, isn't that the element that's after lead? Is bismuth? Someone remember that? I think bismuth is right up there with lead. I believe that's what they use now for the substitute for lead for solder. Something called a Hamel cone and sensors, various experimental devices. Here's a nuclear magnetic resonant battery. Has an aluminum layer, a copper layer on the outside, a central magnet in the middle, and so on. Talks about Searle disk and how that works. And that's about it in terms of that little episode. So people might find that interesting and useful. It's at www.resonantfractals.org/magnetism. Some great information there. All right, any questions or anybody have some comments? Anything else you want to say about that? Let me find the live stream and see if there's anything going on that end. Okay, does anyone have something they'd like to show, perhaps, then. We can get out of this quite easily. Go on to something else.
I have, hello everybody. Hi, Rick.
Hi, I just realized I didn't have my headphones on, so it's probably echoing in live stream right now. Sorry about that. Just getting that geared up here. So go ahead, that's Mario, right?
Yeah. About 8 years ago or so, I had a skin cancer thing, yeah? And I had surgery and all that. And I don't know how long, maybe 6 months ago is when it was obvious, probably a lot longer than that, when it started. I started to get what looked to me to be the same thing. And I don't know, it took me until a couple of weeks ago. I thought, hey, I just put a little bit of CO2 water on a towel, a tissue, paper towel, and sort of rubbed it on it. And a few little things on my face, I could feel that, hey, what's that? You know, couldn't see anything. But I've been using that for about 2 weeks, and it was really haphazard. I think a couple of days ago, I decided I'll do it like medicine 3 times a day, you know? And it's totally reversed. It's shrunk. It's going the totally opposite direction. And I'll see how, just keep putting it on there. I'm pretty sure in a couple of weeks it's completely gone. It's totally anecdotal. I didn't have a biopsy. It's not a testimonial, but, you know, for me, I just know. I go to the hospital, they're going to go, cancer, cut, you know, 10,000 baht or whatever it is. You know what I mean? It's going to be an instinct. And, you know, it's going away. And to me, I think I just cured myself of cancer with some water and a paper towel. It's amazing. CO2, and I was trying to think.
Sorry, let me get that on live stream. I didn't have my mic on there. That was the CO2 Gans water. Is that what it was?
Yeah.
And you said yes?
I'm wondering, you know, I got to know what layers and what I'm dealing with there. Just add some CuO or probably not CH3, right? That's the opposite, right? Just stick with the CO2 for now.
Yeah, I think
Well,
that's what's been recommended, basically.
yeah, CH3 isn't necessarily opposite. It just adds energy to the system.
Yeah, the opposite. Well, I don't know. Maybe not. It works.
Some cancers, when you add energy to them, they overexpand and die because they're already growing rapidly, and then they grow too rapidly, and that's what actually kills them.
Yeah, well, at
But
this
on the other
stage,
hand, if you go to a hospital and they want to make a tumor show up in their X-rays, they just inject you with sugar in your blood, and the sugar makes the cancer aggravated and grow faster and show up in the X-ray. So maybe we don't want to feed it necessarily with the CH3. I'm wondering.
no, that's what I meant. Yeah, that's what I was thinking too. It would feed it. Yeah, I mean, it might blow it up, but I don't want to. If it's going the other direction, I don't want to. So, what about the CuO though?
I tend to not want to use the CUO. I'm hesitant on that stuff, even though it's just the water. But
Yeah, me too. I wanted to hear a confirmation of that. You think that too, right? So I'm just
yeah,
sticking with
like
the CuO.
Kesh mentioned in treatments of tumors and whatnot a few teachings ago, not to use the copper oxide or the CH3, but just the CO2 GANs in terms of that particular time period at least. So it seems some things can be treated with the combinations depending on exactly what you're trying to get to. But I believe for tumors that, or for skin issues, that the CO2 is best. I've tried similar experiments as what you say. I have a rash that I get on my hands sometimes from exposure. Like if I get a tiny smudge of grease or dirt like that on my hands can break out and actually bleed from it and so on. But if I use a little spray of the CO2 Gans water, and I don't care if a bit of the Gans gets in with it, that's fine as far as I'm concerned, then it just seems to calm it right down. All the itching and irritation goes away. Next day it heals right up faster than anything else I've ever seen. And it's, yeah, more or less like a miracle, like you say. So I've tried lots and lots of different substances on my skin, and almost every herbal remedy will cause extreme irritation on my skin when it's inflamed. And so I know whether something is causing a cooling and calming effect, or whether it's inflaming and irritating. And um, I'm amazed how cooling and how calming that particular substance is. So definitely, we're both testimonials to that, I'd say.
Well, thanks. Yeah, that's what I need to hear, man. I'll keep you posted, man.
Yeah, I didn't
Thank
want
you.
to talk about that at one point because we weren't really supposed to be advertising about the using the GANs and that kind of thing on our skin or in the body and so on. But tests have shown recently that that 9 out of 10 lab rats love CO2 GANs when it comes right down to it, and they tried to overdose them with some, and they all survived and did quite well with it actually, and got rid of their colds that they had and given them as well. They inoculated the lab rats with influenza bug, and the CO2 GANs helped with that somewhat, and especially helped with the radiation. They gave the lab rats radioactive stuff in their food, and it killed the rats within 1 week, except the ones that were doing the CO2 GANs. They did not die. They kept living, and as far as I know, they still living, but happily married and having kids and a
The
picket
rat that
fence.
wouldn't die. Sounds like a bad B movie.
Yeah, don't give your rats GAN. Don't let the rats in your house get at the GANs. They'll live forever.
I think I have something else that might be interesting. I always had ants. It would be on the balcony mostly, but there'd always be an ant just crawling across the floor. Or if I
Yeah.
left something out on the kitchen suite, I might get a line of them, but they're not really a problem. But all that CO2 that went down the drain. And, I had so many bad batches of gas I dumped. I don't know how much, I don't know, man. Maybe the building called it an exterminator for all I know, but I don't know if you could,
Well,
how,
strangely, I noticed the same thing in the last year or two at my place. I used to quite often get ants certain times of the year. They just sort of march in, and first the little ones come in, then the medium ones, and then the big ones. And you think if the next ones come in, they're going to be the size of mice. But yeah, and this has happened for years here, and I've sort of dealt with it and so on. But now, for some reason, they don't seem to be here. So
you're getting
I'm
another
not sure
food.
if it's the GANs being around or just the vibes, or whether they're getting what they need already outside, or what's going on there. But yeah, it's interesting.
Well, okay. Thanks, man. Thank you.
I do notice I get a strange little bug that comes by every so often, though. And that's been happening for the last couple of years. Every few months, I get this strange little black, sort of dark bug that'll come in and want to hide under my keyboard. And I carefully put him outside because I think he's special. But he comes in again, and it's happened 4 times that he's a similar bug. Can't say it's the same one. Has come in and placed itself right in front of me, and then tried to hide under my keyboard. So, what's with that? I think Gans makes things do strange things, perhaps.
there's a coincidence. I had exactly the same thing when I was in Shanghai. Exactly the same thing. There would be these, I was on the 19th floor, and there would, at a certain time, just a few of these, more than a few, I guess, certain kind of insects would come in and they would just come right and land on me. And I'd be like, wow, and they're flying, you know? And then they would run around the room and they'd land on me, you know? And I would like shoo them off. And then they'd be gone like the next day or whatever. I don't, you know, what are you going to do with them? They weren't biting or anything, you know? And they pretty much left me alone. I slept, but they just seemed to come and say hello or something, you know?
Well, it makes me wonder, maybe what if insects are raising their evolutionary level? And what if they are becoming, well, intelligent to some extent, or you know, reaching out to communicate in some way, for example? I mean, could this be happening on the planet? It seems like other animals and humans are evolving. It seems like we're all, you know, moving up a level at this point. It's sort of graduation time on the planet. It's evolve or devolve time. So perhaps, you know, animals seem to be interacting almost like humans. We see them doing all kinds of what appeared to be intelligent and, you know, interesting kind of situations that they're getting into. And we've got, for example, chimpanzees and gorillas communicating with iPads from zoo to zoo. And they're actually able to communicate with each other through iPads. I mean, what kind of crazy situation is that? We've got, you know, goats that are surfing, and we've got seals that play volleyball, and all kinds of stuff going on out there in the crazy world. So why not bugs that are bugging us because they're trying to communicate? They're doing what bugs do, bugging us. I don't know. Maybe we're getting a little far afield here, so to speak. All right. So what else have we got in for action and out in the world or in the world? Here's a question from Chad in the live stream. Hello, Keshe Plasma Technology people. I'm 1 month into learning about Keshe technology, and I'm teaching myself the fire coating for making pens. I would like to know, is it bad when the wire glows? What I mean is, will the wire flake if it starts to glow orange or red using a propane torch? Any comments on that? I thought John might want to weigh in on that.
Yeah, it's getting it too hot. You want to get it to just a point where it starts turning a silvery color and then start moving on. But if you get it too hot, you will nano coat it, but the coating will be very, very fragile, very weak, and it'll just flake right off.
Yes, although I note that the melting temperature of the copper oxide is higher than the copper itself. So technically it might be possible to keep the coating and still heat it up to a red hot or near red hot temperature and have it still nano coat, you know, continue nano coating after it's cooled down. But the chances of burning that off, there's only, I think, a 50-degree difference or something like that. So you'd have to have super sensitive equipment in order to ride that fine line between destroying the nano coating.
Yeah, when this first came up, what came to my mind from my background is the thermal expansion coefficient, where your coating is not going to expand or contract as fast as the copper itself. And that's why it's if you get it too hot, there's too much stress placed on the nano coating, and it just comes right, because it does. We've seen that so many times. Lots of people do this with the torch, and their coating just comes right off.
Right.
I think it has to do with that thermal expansion coefficient. I can't think of any other factor that would be in there.
Yeah, I've experimented a bit with pennies as well, and that was quite interesting. I'm not sure if I have those pictures handy. No, I don't. I took some pictures of the actual flaking of the coating, and the coating, the nano coating. Let me see if I can find those. It's actually relevant here if I can. Okay, I think I have to open a different library. That's probably where they were. Okay, well, bear with me for a minute because I'll see if I can find that. Let's see. One. This one. Yeah, so anyway, the idea was that the jeez. Okay, maybe I can get it to work here now. Okay, I got the library coming up. So what I did was I put pennies on the burner of my electric stove and heated them up to basically a red hot condition. Oh, let me see if I can find them here. Just a minute. Back into the past. So many strange things back there. Oh, jeez. Oh, there we go. Okay. Let me see here. Okay, I'll do the share screen thing. There you can see the pennies on the burner there. Let's see if I can. And this is after I put pennies on in a series here, starting at this end and just kept putting them down on the burner, and they got hotter and hotter as they, like the coldest one is up here, and that's hotter and hotter and hotter. You can see the black coating that forms in the time it takes to put these pennies down, essentially. So as soon as they start to heat up, they start forming this black coating. But they also go through a series of colors and beautiful, purples and greens and whatnot just before it turns to the black as well. Let me go on here. You can see they all are black now. And I tried to heat them up more. You can see these are actually red hot now. And when they cool down, they still have the black coating.
Were those old pennies or new?
Well, they were old pennies in that they were all solid copper pennies before 1985 Canadian.
Okay.
Let's see, what else did I have here? Let's have a look. Oh, that's where I was nano coating them. Ah, here we are. So this is what happened to some of the pennies. I think this is when this is like when the coating started cracking off of it from cooling too quickly.
Yeah, I see a very similar thing when I was heat treating steel with the carbon film that forms on the steel. when you quench it, that film like flakes off because
Yes,
it
right.
doesn't move when it cools, and the steel does.
Right, yeah. And it's interesting that, for example, here's a flake. You can see the outline of the queen's face that comes off in the flake itself. So it actually conforms to the surface quite exactly when it comes off.
Yeah.
It's kind of a crystalline type structure as well. And then you get sometimes the reddish as well. Was it copper 2 oxide or Cu2O? CuO2.
Is that the cupric oxide they're
Yeah,
talking about?
yeah, that's right. So that can be formed sometimes as well. In fact, you can use this cupric oxide on a penny to make a diode that it works for a crystal radio crystal. You
Oh,
can use the actual penny as a crystal. And that's it for that run. So anyways, interesting. I was thinking maybe pennies would be good to work with in our Keshe reactors in some way. And also to create batteries and plasma batteries and whatnot.
Donaldins.
Our pennies in
Hello,
Canada.
everybody.
Hello.
Good to see you guys. Hello, Rick. Hello, Vince. Hello, John. This is Sylvester.
Hi, Sylvester.
Sorry I could not come earlier. I had some meeting. Good to be here.
Great. So yeah, what I was going to mention is pennies are interesting. That some of them are pure copper, others of them are copper clad. They're basically copper coated or copper plated, but there's zinc inside. Some copper pennies are zinc inside, so you can actually shave off the copper coating, and then you have copper and zinc. On one side of the penny and zinc on the other, and you could put that together with a copper penny and then zinc and so on. You've got copper and zinc plates, and in fact copper and zinc both on the same plate, and then you can nano coat the penny with the copper and zinc on it, and you would have a nano coated copper plus zinc plate all in one penny. You can imagine that. There's other pennies that have a steel center. They're actually steel with copper clad, and they're magnetic. You can tell they're the steel ones because they're attracted to the magnet. Anyway, a little bit of penny history there. When it comes to American pennies, it's a different ball game, but similar. Okay, what else do we have to show and tell here? Okay, here's a question for you, John. If in live stream, Ron says, what I've failed to find online is the exact size for coil form diameters. One guy said 4 and 10 millimeters was the size he's used, but even the drawings don't mention exact diameters that I could find. And he says, I'm not used to metric scales for anything. So what would you recommend, John?
it depends on your wire diameter. You want your outside coil mandrel to be just a little tiny bit bigger than your inside coil mandrel plus 2 times your wire diameter. You want it as close as you can get. If you can get it down to between 7 and 10 thousandths of an inch, fantastic. You'll have an excellent working system. If you go as high as 32, like a 32nd of an inch, then you're going to start losing efficiency once you get past that point. But this is why, is because it depends on the wire diameter. If you're using 14 gauge wire, which is 0.064 inches, basically twice that is an eighth of an inch, a little bit over an eighth of an inch. So you need a little more than an eighth of an inch difference between your inner mandrel and your outer mandrel. I know Rick understands that. He's a technical guy, but is anybody else in the panel here? Do they understand what I'm talking about?
And more importantly, does the person Ron understand, I wonder, in the live stream? And if he doesn't, maybe he can make a comment there and we can clear it up. Thanks, John. That's cool.
Okay.
I see that Guy is right on the ball here and correcting us about the cupric oxide. It's actually cuprous oxide. Cupric is the CuO,
Oh,
which is the black stuff.
I never even heard of it until about a month ago when one of the folks in Europe said the word, and I thought it was a problem with translation. I didn't know it was actually a thing.
The cuprous or cupric or both?
Both, either one. Take your pick.
Mm-hmm. Yeah, there's a good Wikipedia insert on all that. That's quite interesting once you get into it, actually. Okay, trying to look what else we got here. Anything else for show and tell among our participants today?
No, I've been busy with meetings and dealing with the house to be building anything lately.
Yes, I've been preoccupied myself as well. Okay, where's our...
I can add one thing.
Sure.
Remember you told me that wool was magnetic, or it worked. I had attached wool to my ping pong balls. Well, all of the innards of my ping pong balls got pulled out, got wicked out by the wool, except for one which didn't have the wool inserted into the ping pong ball. It was on the hot glue instead. So just a confirmation, do not stick wool into anything. It will wick whatever's in there out. So thank you. I learned.
So you put the wool inside and outside of the ball at the same time, like it was like
Well, no, I had left a string of it inside the ping pong ball, thinking that it would be a good thing.
Mm-hmm.
You did mention be careful it's magnetic or it will make. I think that's what you said to me.
It's an electrostatic substance. Well, they use it, for example, to charge up things and so on. If you want to, balloons. If you want to charge up a balloon, you might rub it with a piece of wool.
Okay. But there was one ping pong ball that I didn't do that to, and it's still full of the contents of what I put in it. And so I was.
I'm trying to get clear on this. You're saying you put the wick of wool inside the ping pong ball of
Yep,
liquid,
so I could hang it from my clothesline,
and it dried up the stuff inside, or
yeah,
what?
it all disappeared. And I only found that out after I'd moved. I'd collected everything, and as I started to unpack stuff, I found all these my ping pong balls were empty, and then I found one that wasn't, and that was the one that I had reopened. I'm not sure even why I did it, but then I had closed it with hot glue and put the wool on top of the hot glue, and that's still full of its contents. So I thought, Rick told me about it being like I heard magnetic, and that's true. So I was just trying to confirm: don't put the end of wool in anything, because to me it wicked it right out. Whereas I thought if it rained, the rain would go in and keep it liquid, like would add to the moisture, but it didn't. So just that's my understanding anyway. So I wanted to share that. I thought, I got something I can share.
Well, who knows? Somebody out there may need to hear that. So thank you, Libby. It's not up to me to decide whether or not it's relevant, because who knows? I might be using wool myself tomorrow for something or another. I never know. I just use what sort of comes up in the moment and so on. I was browsing today and looking for some other things, and I found these nice little test tubes. These are actually plastic, and they have a nice little cork and so on. And They were quite cheap at 40 cents each, so I couldn't resist getting this little package of 5 at Princess Auto for those in Canada that frequent such places. They have
What were you saying about the cork that goes with the, to be careful with the cork or?
Oh, well, John was mentioning the cork that comes often with these test tubes and so on, and also with the little, you often have a cork with the little kind of bottles like this that people have that hang them around their neck and so on. And that, especially if you have a bit of salt water left in your Gans that you've put in there, then it can tend to work on the inside of the cork and deteriorate it and possibly turn the cork into Gans of cork, is what John was mentioning. Isn't that right, John, basically?
Yeah, that's essentially what we saw happen. A lady I gave a bottle of Gans to gave a little bit to her daughter, and she had a little bottle with a cork in it. And 3 days later, they get a hold of me and goes, "What's this stuff growing on the bottom of the cork?" And it was this kind of beige colored slime that was growing on the bottom of the cork. And I got a chance to get a hold of Armand, and I asked him about it, and he goes, "Well, it's probably because their Gans wasn't clean; it still had salt water in it, and you're making Gans of cork."
Great, thank you.
Here's some substance, for example, that when you pull the cork off, you can see the cork has this blackness sort of thing happening in part of it. And I don't know if it's, yeah, it's all soft. And it's so soft that it's just gooey. It's literally gooey. Look at that.
Well, the ones I've got 3 bottles of Gans. I've got COO, CH3, and lead Gans in little bottles with corks in them, and I'm really fussy when I clean it. And I'm using probably 6 times the water that the volume of Gans that when I clean it. So I'm pretty certain that the salt content is extremely low, and I'm not having any reaction on the corks at all. On these 3 bottles, and they've been sitting there about 2 weeks, maybe 20 days.
Anybody else who's had any cork experiences with their Gans? It would be good to get some other feedback on that to see if there's been issues with certain kinds of Gans maybe affects the cork and not others. I'm wondering, or I mean, definitely if it had caustic, for example, you wouldn't want to be corking up caustic. That probably would be ineffective, but generally people won't be doing that. Go ahead, sorry.
I was just going to say, it's Tony from Australia. Gans of cork may be really useful if you're planning water landings in your spacecraft.
Good one.
Just something to keep in mind.
Yeah. Or if you're making wine out in space and you forgot your corks for the
There you
bottles.
go.
Now you're talking. Sorry, that wasn't really useful.
No, we need a breakup of humor every so often, and especially in this particular show. So, thank you. Okay, looking for more inspiration out there. Let's see, what have I got in my... I think there's lots of people who have sent stuff. I see a little bit of conversation in the live stream.
Do you have the pictures of the freezer test the fella did with a pain pen? But he did it in a very long, tall container, and he actually had 4 nodes, 4 balls in the center, and the bottom ball showed that same pattern of bubbles expanding out as the field dissipated at the bottom of the glass. Very cool picture.
No, I don't think I have that one.
I haven't been able to find it. I saw it in one of our meetings. It was shown in one of the meetings, but I wasn't able to grab it at that time. But for the people who say that this is just the way water freezes, this water doesn't freeze in 4 concentric balls running down the length of the glass.
Yeah, I was going to say it'd be really good to do a controlled freeze test when you're doing that. So you've got one, has the pen, one that doesn't.
Yeah, we
I
got one
agree.
coming, and there is one on the Golden Age of Gans. I noticed that somebody actually did that test. There was a fellow who did a test with the pen on the side of the glass,
Mm-hmm.
and we had the same results, but it was horizontal.
Okay,
So
very good.
we're getting more and more information, more and more data that shows very clearly this isn't just water freezing.
Right on.
That's
Good,
great.
good.
For that, John.
That'll be very effective for advertising and for the old convincing factor for those who are doubting there's something happening with these pens and so on.
Yeah.
So it'd be good to get, like he says, more controlled experiments. I think there's some Romanian guys that are doing part of that experiment.
Yeah, I wanted to do one myself. I tried to set it up in my fridge, but my fridge is way too cold because of the ice maker, and the ice just freezes and explodes in the glass.
That reminds me, I did have one little experiment set up just to look at how
Just
Oh, there it is.
something freezes
There
and
it
go
is.
grab it.
I'm just showing Rick image which John has actually brought up. This is the image done by the Romanian guy.
Oh, cool.
We will suggest the gentleman to use some paint to color the formations. He also have a series of pictures showing like how he did it. Basically the known procedure, but the only difference, this gentleman put a glass of water in the top as well. So now we can see, what's going on the top.
Yeah.
And let me have some images, about the positioning.
Yeah, but it's for anybody that wants to say, "Well, that's just the way water freezes." Water doesn't freeze like that. It just doesn't.
Yeah, and let me show you another picture, the way of he's positioned. This is basically the positioning, how he did it.
Yeah.
And I think, yeah, this shows even the previous picture which I shared. This even show, very nice pattern. And I will show another picture.
Yeah, this fits along with what Vivek found when he brought his pens to the Qigong guys in Singapore. One of the pens that he made, the emitting end of the pin was too short. It was too close to the end of the coils. And the Qigong fella mentioned that what he's feeling, the energy coming off, is coming out in a pulse. And when we saw the inside of this fella's pen, his emitting pin was very, very short. And what we think is going on is that the energy as it's leaving that center pin is interacting with the toroid field that's being created by the coils. And some of that energy is being drawn back in, and it's creating a pulsed type field. And I think that's what we're seeing here is that pulsed field.
Yes, I think you mentioned this, like it's very important, that the size of the wires, how long is it, to basically become more of the spear, or emitting out. And as you can see in the end, because this you see up and down, switched the direction. What you see in an upper level, that's basically the bottom of the bottle, which is froze down. So you can see the energy is basically spreading out.
Yeah.
Yeah, that's a great shot.
Yeah, the more people do this, the more data we get, the clearer picture we have of how these things are functioning.
Yeah, I know that the Austrian manufacturing team, who's right now currently working together with the German team, the Austrian also emitted the same type of crystal study through one of the Austrian university professor, what the Hado Institute do in Japan with the late Masaru Emoto. I personally worked together with the Hado Institute. So the Austrians also following the same thing. I stopped in my share.
Okay, bring it up again, Rick. You were on a little picture. We couldn't really see it. Oh, he's still muted. Let me see if I can fix that.
There we go. I was just playing around with freezing in a little cup here, and you can see the well, when the bubbles freeze, they go through the water and form these little tubes essentially. But all the bubbles went toward the middle on this one. This was in this sort of form though. It had this inside of this, which was inside of this. So it's kind of a double walled kind of deal. And it had this little ball in the middle. So maybe the fields were attracted to that ball somehow and formed those strange bubble tubes that went toward the middle. Whereas another one that's...
Sorry, Rick, what is inside your ball? What type of Gans?
It's not a Gans. It's just a... it's a ball.
That's a personal question.
It's water of some sort in there that's used for freezing.
Is this a personal
question? It's just a regular one. Anyway, I'm going to be playing with that more. It's doing a meltdown over my desk right now, so this didn't work too good. Help.
It'd be great to see what different containers around the pens, what difference it makes as far as different thicknesses of plastic or wood or, you know, whatever.
That would be a great experiment to see if, you know, different materials for the pen itself are those wooden ones that John have that, you know, the best in the world. That's what we want to use for the Keshe Foundation Canada, right? So it'd be good to have some sort of comparison that way, that we could see right there in front of us in frozen fields, the different effects of different items like that. So
yeah, I was wondering if like a gelatin, if we could do the same sort of thing with a gelatin. Excuse me. Because the freezers, you got to have the conditions just right to get nice, clean, clear ice that you can see. And that's one of the issues I'm having is my ice is not clear. It's really cloudy and it just shatters in the glass. So I can't really get a clear in the field.
Distilled water?
Sorry?
Are you using distilled water?
I've tried it with distilled water. I've tried it with filtered, with RO, a whole bunch of different kinds. It's just my freezer is too cold. And because the ice maker in my freezer, it needs to be about 0 Fahrenheit. Otherwise, the ice maker doesn't work and it freezes too quickly.
Another thing, gentlemen, last time we had the meeting with the Canadian manufacturers and the Canadian foundations, Armin had to leave earlier, I think, and I think about the design of the pen. Armin showed recently a very nice design which can be worked to polish it down to the finished product. I think by talking the housing of the pen, what John presented about the inside and the whole concept, we could talk later with a separate meeting with the Canadian manufacturers about the design that Armin preparing. And maybe we can polish it down to the finished product. I think that would be a really good candidate. What do you think about this, Armin?
Guys, do whatever you like.
Yeah, I know it's a very good concept, but
stand it and do whatever you like. Why are you asking me?
Because you're the one who created.
And you produce it. It's okay.
Okay, so let's call it. Let's have a meeting on this together with the manufacturers, John and you, Rick, and let's work on it.
But it's not on point of creating a pen. Pen, we know it's a direction of the plasma. How about the mixtures? What mixtures we put on it to transfer the field? This is important knowledge that we have to come, let's say, chapter by chapter. Like explaining people, okay, you mix with this, with that, you get this kind of field, you get funny field, or you get, happy, or you get sad field, or you get this field. This is a point that it's going to be, and it's going to be so fast because people are going to try it.
Nature's outside hands. That's what we need.
It's a total concept what Armin created, so not something which we see nowadays, commonly. He's playing around with the container, small container of different Gans and liquid Gans and with plasma and things like that. Okay.
Gans of maple syrup. I think that's what we need.
You can
Yeah,
get,
you brought it up last time.
It's
you
going
know,
to
so
be our
some
secret
people,
weapon.
how to Gans everything. You just how in your stomach it does, body. You know, you create acidic condition which brings to molecular structure to atomic structure. Then it's a Gans. It's a free energy. You know, they exist because they have that field, copper field, in a Gans state. So you release it from the matter, and that's it. And it's same thing you can do in a salt water, or same thing you can do in acid. But you mix it together, it comes up, like the substance in your stomach. You have salts, you have potassium, you have hydroxide, and you have salt, Na. Mix it together and make a solution, and you will see how you Gans it. You can Gans it anything.
Good point.
Then wash it out, let the sauces settle down, wash it out several times, put it in the distilled water, and you have a Gans of, I don't know, whatever you Gans it. So
Maple syrup.
you can do anything.
You can even
Whatever you add in a soup, you have to understand what container, today Mr. Keshe explained even the container, it's a plastic, correct? We release some, high, CH right over there. So it's an energy source. So then your substance contains every field, whatever, even from the container, from the water, you have to know what's in your water when you do your caustic process, because everything comes in the soup. Then you just wash it several times, you see there is no solidity in there. And that's it. You have a Gans of it. You can reuse that water for centuries because they carry the field of it.
Armin, what do you think about Jackie use another substance other than caustic to produce the Gans? This is the way how to create the three-layer effect, so to speak. When you have this three layering other than you have a two layering. Rick, you remember when Jackie presented?
Yeah, well, I was gonna mention that. Go ahead.
Like you put an oil, glycerin, and water together. You will see the separation.
Yes, but no.
But he did it with acid, though. He used caustic on one side and hydrochloric acid on the other, which are both at opposite ends of the scale of pH, basically.
Definitely. It's all pH. It's acidic or it's alkaline.
Right.
Check your waters when you do your Gans. Check your waters. You have a alkaline water when you do caustic.
Yeah.
Correct.
He used both, and he was able to get that separation in his materials by.
But in the separation, like your body, in separation, you carry all the salts, 12 salts, correct, in your body.
Mm-hmm.
Why you carry it?
As James mentions, HCl and NaOH creates brine.
No, it's alkaline. Bring to the point.
Well, no, HCl is the acid. You put acid and base together. You put acid and caustic together. It creates a salt, basically.
Yeah. So.
Yeah, for example, you can use vinegar and salt, which is an acid and a salt, and put your copper into it, whatever kind of copper, and let it soak for days and days, and it'll start to turn blue. And then you can pour caustic into that, and it creates black copper nanoparticles.
Mm-hmm.
So it's just like what you were talking about there, Armin, in terms of using acids and bases.
Softening the material. Everything what you put in your stomach, you're softening the material. You're breaking down into atomic structure, molecular structure. Mm-hmm. And every element it's mixed in your stomach, correct? You have iron, you have copper, you have carbon, you have everything. So it goes through your intestines, you pass the field to your water. So now your water carries everything what you ate that day, plus what you reserved in your liver, correct?
Mm-hmm. Chad asked a question in the live stream. Is it standard that you will feel a cold plasma flame an inch from your hand with a well-built pen?
Yes, correct. You feel it right away. If it's a, if you have a, the pin is like tube, it's like laser.
Yeah, we mentioned this a bit, I think last time.
Yeah. It's like a ring magnet and a solid magnet. Today even Mr. Keshe explained that. With the ring magnet, you just disperse the field. Well, with a ring magnet, you just point it like a laser.
Mm-hmm.
So it depends what application you're using for.
Do you want a pointy paintbrush or a wide spread paintbrush?
Maybe you need both.
Mm-hmm. Certain times you want a pointy brush for
That's why
details,
sometimes
and
you need three pens to work together, correct?
yeah, sometimes you want a 8-inch wide brush for swabbing a large area, perhaps.
It's a field transfer. Whatever coils you have, it's a field transfer. It's in the metal level, so.
So it'd probably be fair to say that some people might feel the cold plasma flame an inch from your hand, from the pen, but not everyone will necessarily feel that. In fact, some people might see the fields. Some people can see it rather than feel it, apparently. And others may not be able to feel or see anything, but they still might receive the beneficial effects of the reduction in pain or some sort of healing effect.
Even when you are so sensitive when you have a cut. When you point the field, like your pain pen, right away. When it's a fresh cut, you feel it right away.
That's a good point.
So really,
someone may not feel that cold plasma when they put the pen on their hand, but they might feel the cooling effect from the pain reduction or irritation reduction that occurs.
No, it's like something connects to your neural system right away.
But not everyone will feel that necessarily, right? Depends how tuned in they are.
If you made your pen properly, you transferred the field properly, so you will feel it because it's higher than you, and it's concentrated direction.
Okay, good point. Thank you. What else you got to show there, Armin? You got any secret projects you want to give us a bit of a hint on, or?
Hell no.
Oh darn! I thought I could convince him.
It's not ready. Otherwise, I will show it to you guys.
Right. You've always been quite forthcoming in all
your
new stuff.
What is it?
I say you've always been quite forthcoming in the things you've presented, and whenever it's ready for prime time, you get it out there to people. So appreciate that, Armin.
The star formation that we had in Desenzano, I'm trying to replicate that with two cores, one inside, one outside. You can fit it different, Gans water. It's sealed properly, and I have a copper core made that time, so whatever I had in my hand, the way I can use it and show it to you guys. Both cores are nano-coated, and so when I assemble it, everything is ready. I'll show it.
And the central core will be spherical, or are you going to be using coils?
I have spherical, and I have not coils, but I made a butterfly type of rotational mixer. You just have to understand the mixing point is just when you open up in a big, let's say bigger sphere, the fields you see there's a field like emptiness. creating when you rotate the ball very high. Even the glass balls, when you rotate the high and you have little bit air left, that air it opens up because
Yeah.
more rotation. So that mixer, when it touches that wall of emptiness, it creates a rotation. It spreads the fields. This is how I understand.
Yeah,
We
Keshe seemed to give us a clue last time. Sorry, go ahead.
We need that bitting from
The
inside.
beating, yes, that's what I was just going to mention. That Keshe sort of gave us a clue last time about it's not just rotation and swirling, but there's this beating action that is important, or some sort of it's like a pulse in the liquid.
It's a pulse. It's like your heart is beating, correct? It's pumping. So it's not sonic. You hear the beep, the pump. So you just hear the voice, psst, and that's it. But it's a pump. So that's what it creates inside. Otherwise, if you put a straight one, so it's not gonna create. It will still create a friction, but you're not gonna have that beat.
Right, exactly. You want more than just friction. You want the beat. You got to get with the beat. Interesting.
Ask any questions you want. Maybe I will have an answer for you, but I don't know what you want.
Well, now's your chance, ladies and gentlemen. Let's pin Armin down to something here.
I have a couple of questions.
Oh my God.
Okay, here comes Mario. Let her rip,
Now you
Mario.
Under a box.
One of the things is, if I
Let's talk about the power units. How about that? How we can make,
Well, let Mario get his question out here because he's probably got something in the sleeve there.
Oh, okay, I'm sorry, Mario. Go ahead.
Sorry, I'm taking advantage of your presence here. If you want to make a Gans of gold, okay, standard way of doing it. But if I just need the fields of gold, I'm going to put them in another, whatever. I can just put the gold on top of the container and make my CO2 or whatever else. And it's still getting the Gans of gold, right? Or the fields of gold.
Fields of gold. But I understand you have to have a direct fields of gold. It's going to come out from your Gans.
Right. Right. Okay.
Of
course.
It's in a plasmatic condition now. Sure,
Right.
matter is a plasma too, but in a different state.
But I've already got it mixed and I can't change it later.
Now you have a free state that you have a field of the gold. If you put the water, it will transfer to the water.
Right.
Yeah.
Thank you.
You're welcome.
I have a question about your reactor. you spinning, if you have the double coil, right? One of them at least, or several of them. You're spinning that coil, both those coils in one direction. You don't have the inner coil in one direction, the outer coil in the other direction.
You try it when you make it. You try it. It's in your hand. It's direction. What if you turn the outer core other direction, inner core different direction? What's going to happen to the fields?
Oh yeah, I understand that. What I mean is the mechanics of making it.
Oh, mechanics of making it.
You have on that control. Yeah, you can change the direction of either one.
Yeah.
Plus the ball.
Yes, correct. But let's say if you connect it to the not the power source or directly to the batteries, plasmatic batteries, or if you have a power maggrav unit, you can connect to that.
Right. But if you're going to fly off in
space, you have a total plasma field. Now you have a total plasma field. Because
if you fly, you can't stay plugged into your outlet if you're flying in space. So
definitely, and from outlet, what you're going to do, if you can, actually, it's going to be plasma batteries. But from your outlet, what you're going to do, you're going to have a field, create for materials.
Right.
You don't need to fly away, but you can load your reactors to create any materials out of their interaction. This is next stage. It's coming, guys. When you do your own, testings, you will understand. You just load up the reactors the way you needed it and run it reactors. You will receive whatever you need. That's the point. What we're gonna come on from all of this.
Thank you.
It's a lot of things we can create. We can create a contamination anywhere we want to, extract any material. We can create a higher field of it to extract it. What is the higher? Well, you got to create a sink. What is the higher field? Any material you use one higher, let's say 3 or 4 times, and you have a sink. When you have a lead or you have a bismuth, it's higher than lead. If you have in your course, let's say, a zinc, and let me. A lot of things you can do, guys. That's what, when everybody gonna have a reactors, then we're gonna have a lot of tests to do, and next conversation is gonna be, well, load up your reactors like this, and it's gonna be totally different. So this is gonna be a lot of fun to test and to see what reaction we're gonna get out of it. Approximately, we can calculate, because we know Gans, we calculate 25 until 50% less. If it's hydrogen, we calculate 50% less if it's in a Gans state. If it's let's say copper or zinc, if we have a Gans of it by molecular weight, we calculate 25% less. So we approximately can calculate what kind of plasma we have in our hand, what kind of strength of the plasma we have in our hand.
Do you mind saying those again so I get that straight? The CH and the CO2 is 50%, and the others are 25%?
No, I understand, because hydrogen gas only have 1 proton and 1 electron, 1 neutron. Correct? It's lighter.
So, but you calculate 50% off of those.
Out of it, 50. If it's a Gans, if I calculate the Gans, I will not calculate 1. I will calculate, let's say, 0.5.
All the Ganses.
No, every Gans, we calculate differently. That's why we said 25 to 50% difference.
Right. So how do we know which ones to cut to? You mean it's an average about between 25 to 50% of all of them?
Let's calculate. Let's have a zinc, which we have 60, 65, and we have a 63. It's copper, correct?
Yeah.
So if you have a copper Gans, you calculate 63 divided by 25%. Okay. So approximately, okay, by atomic weight, you have this kind of plasma. This is the strength of my plasma. If I want to create, let's say, with this gold, I can't. Because if I calculate, it's going to be 128, let's say, by atomic weight, divide this by 25%. Okay, 25, let's say 30, so 95 something is gonna come. So gold, I know approximately 198, so it's not near enough this strength to create gold. Understand?
Yeah, I think so. Thank you. Keshe has sort of gone through that several times, many times actually, but it's a bit sort of hard to get a handle on, I guess, this approximation of different substances.
So
Yeah.
is it, sorry.
Go ahead. It's okay.
Is it possible, so you're saying instead of, if I wanted to, I don't need to make the Gans of gold or even transfer the fields of gold into another Gans. I could use other Ganses to mix, equate to
the strength, correct?
Strength of that, and I'll get the gold without any gold.
Correct.
Okay, thank you.
because you use as a strength.
Right.
You reduce the strength because it's a plasma soup. That's why you are add by atomic weight, into the plasma soup. How strong is your plasma? What kind of mixture is it?
Right.
Let's say if you have a table in front of you, let me pull this up.
So how do you reduce that field strength down to matter level?
How you strength that you have an opposite field against it. You can have a piece of metal, or you can have another core.
But it has to be the opposite. You have to change the polarity, basically, right? Or a gradient, is that enough?
No, it's interaction. That's when you get your matter in. You have to create an interaction.
Right.
The matter creates in our atmosphere from upper atmosphere. It rains nitrogen, correct? Because it's interact with the sun's, plasmatic field.
Right.
If you don't have an interaction, what you're going to do? You're going to have a magnetic field going up. Okay, let me show you one thing. Maybe I can explain differently. Yes, if you give me a minute.
Yeah.
Okay. Okay, you see this?
Yes.
Consider this our Earth. How come, you have a field which is coming out, which is magnetical. Let me draw on it. Where's the drawing? Point.
What you've got is just a picture of your whiteboard. It's not the whiteboard, so
Oh,
I mean that's why it's.
okay. Here.
You can go to your other options and
Okay,
whiteboard.
I can do this.
Okay.
Let's say this is your Earth. My gravitational field sits right in this here. Magnetical, it goes out. In the empty space, how come the magnetical is not, totally going out that we cannot see this sphere? Can anybody explain?
Well, it's being pushed down by the sun. Is that what you mean?
No, it's been pushed down, yes, by the sun too, but it goes to dictates by universe.
Mm-hmm.
Because whatever composition you have in on the Earth, that's what it's gonna allow you to be open up as a magnetical. Because this is gravitational. This is magnetical. The atmosphere is magnetical. So now, with interaction with the sun, you get in atmosphere only nitrogen because it's out of the interaction of two fields. That's why you need two spheres. Or you need let's say, a sheet of the metal to have opposite field. Even today, Mr. Keshe explained about the, health units. In one side you have a coil, the other side you have a sheet. Ring magnet and solid magnet. With one you transfer the fields, with one you disperse the field. It's a little bit not complicated. When you do your tests, you will have an understanding. I played with magnets a lot, so I know, exactly, how you can transfer the fields. But with the coils, you can do the same. With the cores, you can do the same. You can have two cores, or you can have a sheet. And out of that interaction, you will have the material that you want. Anything else?
Thank you, Armin. Get your questions in, folks. Ron says, I'm not a diabetic, but I have nerve pain in both feet. What kind of a pain pen would work best for feet?
For feet, doesn't matter. If you can have a, rotating reactor, you can, load it up the reactor the way you like.
Nerve pain in your feet is probably a problem with your back. CO2 pad would work. Standard pain pen dipped in CO2 water would work. Probably even a foot bath in CO2 water would work.
It's just not a bad idea.
Add CH3. When you add CH3, it's an energy you add.
Yeah.
If you don't have an energy, what you're going to do? You drink sugar, cola to get energized.
But wouldn't you want to have, for nerve pain, wouldn't you want to pull the energy out rather than putting more energy in, maybe?
No, it's actually, you create a sink. That's why you use the heavier with the lowest, hydrogen, and let's say CH3 with the lead. You create that sink.
I see.
Anything which is not needed, in a lead, it's higher than whatever we had in our body, so it will dump it. Create a lowest and a highest, and what filters you give in between. You have copper, you have zinc, you have whatever material.
James mentions, does each element not have its own intrinsic properties apart from the atomic weight? Like we were talking earlier about, the atomic weight and comparing and subtracting and so on using that. But does each element have its own intrinsic properties besides this,
Atomic weight, we are calculating to have a mass of the plasma that approximately we know what kind of mass. Let's say if we have a copper, zinc, or CH3, magnesium, just name it. But if we add, let's say, a lead, just calculate and adding a lead, what magnitude of mass of the plasma you will have in your hand.
So there's no particular properties associated with that. It's more just the way of measuring
you calculate
the mass.
The totality, what you put in a soup, by the mass.
Right.
We have atomic mass, correct? Now, if we create a Gans, we calculate less of that atomic mass because we calculate gravitational and magnetical, which is magnetical is your atmosphere. Great, but you calculate it's a totality of that. So when you create a Gans, you just release it from the matter. Now it's not attached, it's singular, it's mono.
Okay, well, James mentions, can you not create a pulse by inserting a short-pinned pain pen into the top of the inner ball, and the pen is used as a drive shaft to rotate the inner ball? So in other words, this short-pinned pain pen would, we've seen tests or heard of tests that the short-pinned pain pen tends to put out a pulse signal. And
You do your tests and let us know.
well, this is what was shown on a previous workshop, that those who were able to feel the fields were saying that the ones with the short pin tended to have a pulse to it, as opposed to that laser type directed sort of continuous field that's generated from the pen normally when it's working properly. A certain type of pen will have a pulse to it. So I'm wondering, he's wondering whether that could be used in a reactor to create that beating or pulse that's required inside the reactor.
I don't know. I cannot answer that question.
It seems like a logical way to look at it.
But if we use, we are using right now a liquid plasma. What if we use a vapor plasma? We can do the same. You don't need to fill it up your reactors with the water. Pass the vapor into your reactors, you rotate it, you still have that field if it's contained. Have a leakage. Understand? Because it's a nano-coated, the whole structure, so it absorbs the fields. So when you rotate it, what you do with it?
Can I ask another question? I put a glass ball in between, empty, hollow, in between two containers with brass on one side and CH3 directly on the other. Did I transfer the fields into that ball?
It's empty.
Do I have a vapor plasma there?
It's empty ball.
Huh?
It's empty ball.
Yes.
Yes, definitely.
What makes you think it's empty to start with? What do you mean by empty?
Hollow glass ball.
So it's full though of air, right?
Yes.
Oh yeah, I guess it is. I couldn't drill a hole in it, so it might. I don't know how they blow it. I guess it's air in there, right? So
yeah, if they're blowing, if it's a blown glass ball, it's full of air and water vapor from the guy's breath.
And
so there's going to be a large component.
I think you can know that too.
But I think it's the crystal structure of the ball that contains the field. So it should contain the fields of the brass and the CH3. There'll be an interaction. Is that correct?
You can transfer the fields into your ball.
I did not. Or I did.
Well, you've got two Ganses, you've got two Ganses of different strengths. You've got a flow from the heavier Gans to the lighter Gans. If that flow is going through that ball, you're putting plasma through that ball. If there's something in there that'll collect it, yeah, it'll collect it.
Well, that's what I'm asking, is if the transferring into the glass ball the properties of the crystal structure, is that a container? Have I transferred do I have a vapor plasma is what I'm really asking. I'm doing that process.
Well, that's right. What if there's air in there, then there wouldn't necessarily be a vapor plasma, or can there be air and a vapor plasma at the same time?
Right, I guess that's the question.
You can do that. You can do that with your coils. You can put a little bit field of it, and you know that you are giving more to gravitational and less to magnetical. They have totally different effects. You can increase it or decrease it from your plasma batteries. Just the field. You increase or decrease. Whatever you put on your coil, it will transfer the field in a second. You put a drop of the lead on it, it will transfer that field in a second because you already have the flow.
So then you're saying I'm correct. I have a vapor plasma in the ball.
I don't think so.
Oh, you don't think so? Okay.
No, because you have to transfer it.
Because of the
First
air.
of all, your ball inside is not nano-coated. Why we choose the glass ball? Because the glass ball, when you put the liquid in it, it holds it. But liquid, is it already in a plasmatic condition?
Right.
Whatever inside it will be plasmatic condition because it's a higher strength.
Right. I can transfer to the liquid, but I can't transfer to the air inside the ball because it's not nano-coated. I get it.
No, you know what I think, you have to think a little bit different. Let's say if you have the same connection, let's say from the same material that you make a nano coating, and if you keep that water and you do the nano coating next, let's say your plate, it's connected right away. Because I always keep the mother, whatever I do the nano coating, I always keep the mother of it. Then whatever I nano coat, if I put even a few drops of it, so I carry it the same. Any my appliances or anything what I connected, it will be totally in working right away because it has a connection already. That's why we can create the tools that we don't need to transfer the energy. We can just absorb it from the environment because we already have, let's say, the unit working in our house. Our appliances. We can transfer the field, create a small unit from the same that it's right away absorbs whatever it needs. These things will come up when a lot of institutions, they're going to come up and do the tests for it. A lot of public, they don't have that luxury to do all these tests. But a lot of them, they will, if they understand. Just Gans it everything and try to, play with liquid plasma and vapor plasma. If you have a nano-coated, let's say spheres, a copper sphere or any sphere, which you can nano-coat, even the plastic, not the plastic actually. Plastic is with the carbon. So, when you think what Mr. Keshe is saying, it's true. Because it has, our carbon is a connector. Just Gans it everything and to start to play with liquid plasma, then you understand the difference. Then we go to the field plasma, and it's going to be totally different. Now we have a matter which we can convert to the fields. And we have a nano-coated, let's say, wires that we can direct it. Both ways we know how to direct the fields. You have to do some tests to understand that. Otherwise, one person or two person is not enough. That's why we need to, spread this knowledge wisely so everybody can understand and do the test and give us the reports. And we can learn from them. And they can learn from us.
So Armin's Lee here. I got a question for you. When we were spinning those the copper coils inside the plasma water in our little glass spheres, what do you do with the input wire and the output wire on your coils? How do you connect them to anything, or what do you do?
No. You just connect it together, all together.
Just connect the input and output.
Yeah. Just input and output them together.
Okay.
It's a mixed. Why he's suggesting, like coils, you can do not coils, you can do just simple cut it with CNC machine, like butterfly pin, it can mix together. This is all the bitting. It's not the gravitational and magnetical. Yes, you have it, but still you create that bitting. It's impossible to create the coils and rotate it like that in high speeds. It will open up. It will not open up if you do the jewelry work. You have to do jewelry work over there, to create that. But nothing is impossible. Any more questions? Oh, let's talk about MAGRAV units.
Yeah, what about that, Armin? You mentioned that earlier, and as you wanted to talk about that.
We always have to pin to the ground, correct? And we need 50 hertz to start our plasma. Maybe we need less. I don't know. If we try to create the batteries that create that hertz and connect the ground, you have your plasma flow.
And you're talking about a ground to actual ground, earth, the earth ground, or some sort of saltwater sort of.
Ground.
Mm-hmm.
Let's say we do the positive and negative, correct? Negative, we take it from the ground. Positive, we take it from, actually, we connect the plasma batteries, little bit more powerful. Then we start the plasma. Then we need to put the demand. And whatever appliances you connect, it will work.
Do you have any new designs for plasma batteries, or how do we get that?
A little bit I'm working on. That can supply that startup for plasma.
Mm-hmm. Yeah, it's interesting. I was looking at a couple of scientific papers earlier today that mention spheres and the idea of a central magnetic vortex inside of a sphere, and creating that with a pulsed current, basically. And that is the way to create the spin of the vortex in the center. It's just a center pin with a current running through it, a pulse current running through it. So there is even some scientific basis for this kind of technology. It's not common, but it is out there, in various experimenters have played a little bit with this, and there may be more information available that can help clarify our way of approach.
Yeah, because if we connect, let's say if I take the phase from the meter and connect it, the ground, from the ground, it's gonna work, and your meter is not gonna run. You just need that a little hertz to just start up your plasma, because it will go back to the grid right away. Because now you pin it into the ground. Here you go, your free energy. That's what Tesla did. You collect from the, Gans coating and everything, or from the surrounding, the energy, and there you go. You have your ground, you have your phase. You have free energy.
Oh, you make it sound so simple, Armin.
It is simple. Connecting, you will see how simple it is. Take the phase, connect the ground, not the minus, the ground. When it comes out, put your load on it, you'll see how it goes.
That's a good basic suggestion there.
You will have your free energy. That's what Tesla did, correct?
Well,
Collecting
more or less, I mean,
ions from the air.
he created, he had extreme ground connections where
Ground connections, you need the ground
he went
connections.
to great lengths to have a good ground. He had wiring and rods and so on driven down, and also had it all cooled with liquid nitrogen in order to bring the temperatures down and so on, and underneath his tower that he was planning on generating power with.
But he don't need it. If he understood the nano coating that time and nano coated the whole his tower, you don't need all of this. You just need a ground touch. Actually, if you touch your skin, you feel it, correct? Doesn't matter where you touch your skin. On your foot, on your head, on your shoulder, you feel it. It's the same thing, the planet. Different fields, but still it's a from
That's
the
a good way to look at it. You could, Tesla had, in fact, if you look at the video, what was it called? That movie with Tesla in it showed him planting lights in the ground, and they were just stuck in the ground. There's no separate wiring connection. They're broadcasting power with these globes that were lighting up, and it's sort of
he
like
connected both together.
yeah, it's sort of like putting pins in the earth, basically, like we would put a pin in our body, and we would, like you say, feel pain anywhere on the body because it's all one electrical field, and the same as the earth is all one electrical field, and you stick a pin in it as a light, and it
In your atmosphere, it's a more of a plasmatic field, not coming from your ground, from the sun, correct? You collect that energy. Now you have Gans. You Gans coat your nanomaterial. What you do, you collect all that energy and pass it through. Connect to the ground, connect to you see, it works like baby.